Oh, snap. It's everybody's favorite day. It's time for vertical angles. We've actually, maybe alluded to this here and there. It's something that you guys might, see and think makes sense as well. So that's always exciting when something actually kind of sort of makes sense. You know what I'm saying? So this is our vertical angles definition. All right, it says if the rays forming the sides of one and the rays forming the sides of another angle are opposite rays, then the two angles are vertical. I think it's easier thinking about it as like if you got two lines like there and there that crisscross, right? They form two angles. Well, really the rays form angles because by definition of angles, they're made of two rays with a common endpoint. But anyways, when we're looking at that, if you get two angles right there, those two are called vertical angles. And then we've got two other ones, this guy and this guy. Those are two other vertical angles, the ones that are across from each other, right? So what it looks like is two lines intersecting, you get some vertical angles. I think that's an easier way of thinking about it, but really, this definition, that would be the proper way of writing it, with referring to it with rays instead of lines, okay? Now, although this is the definition of vertical angles, there's a theorem about vertical angles that is the actual thing we're going to be using, especially when it comes to proofs or really application. What do you think we know about these vertical angles? So either the black ones with the one tick or the red ones with the two. What do you think we know about those angles? That is correct. Well done. They are indeed congruent. Okay, so the red ones are congruent. The ones with the black single tick mark are congruent to each other as well. And that is our next theorem. All vertical angles congruent. Or if you want to abbreviate it as vert angles congruent, I am cool with that as well. Mr. Brown's a cool dude. All right. So let's see if we can identify our vertical angles that are congruent. Question, are I think 1 and 10, they look to be congruent, but are they vertical angles? No, you don't have that nice crisscross going, right? When we talk about like two lines basically crisscrossing, really we refer to them as rays, if we're going by definitions with the angles and everything. But how about this? How about 3 and 4? Heck yeah, those are congruent. Heck yeah. So 3 and 4 would be vertical angles. So I could say angle 3 is congruent to angle 4, and then my reason would be all vert angles congruent, or just vertical angles congruent as I wrote up above, right? You don't necessarily have to have the all. It works, but you don't have to. Vert angles congruent. That works for me. All right. The other one, you could probably say like 6 and 7 are congruent, although it doesn't look like it's perfectly crisscrossed. I wouldn't leave something like that for you, though, where it doesn't look, or like it looks like, I think it's kind of a straight line right there. Hard to tell. So let's leave it as we're not going to mark anything with those. Let's just go with the 3 and 4 here. So let's say we're given that 2 and 3 are congruent, and we want to prove that 1 and 3 are congruent. How would we do that? So I'm going to mark down that angles 2 and 3 are congruent. Pew, pew. Sound effects always necessary. Alrighty, and I want to prove 1 and 3 congruent. Well, let's think about what we just learned. I could probably say that 1 and 2 are congruent. Why would 1 and 2 be congruent? Well, 1 and 2 are congruent because I know that they are vertical angles, right? We got that crisscross going. Crisscross applesauce. All right? So those are two vertical angles, so I know that all vertical angles are congruent. So these guys are congruent. Let's take it back a day or two here. What do I know if 1 is congruent to 2 and 2 is congruent to 3? I can say 1 is congruent to 3 by the transitive property. You guessed it. Man, you guys are great. I just hear you talking over there. You're like, yeah, Mr. Allen, I love this stuff. This is great. Transitive property. Woo! So you might also be thinking, hey, could I have used substitution property there? Well, let's discuss that, because I love discussing things when it's actually impossible to discuss it, because I'm just here talking to myself basically with an iPad. If somebody walked by, they might not know what the heck I'm doing. All right, so I know 1 and 2 are congruent because vertical angles are congruent. If you said definition vertical angles, I would mark that wrong in a quiz or a test. So you got to be careful. Make sure you are using vertical angles are congruent. The definition just tells us what they are. Cool. We know what they are. The theorem is what you're going to use. You're really never going to use the definition other than you've identified that they are vertical angles. The theorem is what you use. You never really use that definition in practice, okay? So I know that angle 1 is, whoa, sometimes this thing gets a little delayed. It's an older iPad that I'm working on here. It's a third generation iPad. I mean, I got this thing probably 7 years ago, so half a lifetime for you children. Alrighty. So 1 and 3 are congruent, and I said that was transitive property, but could substitution work? And the answer there is yes. I would not mark it wrong, but it's a little bit dangerous to do that. My rule of thumb is when you're linking congruent statements together or linking statements of equality together, use transitive property, okay? If you're plugging something in, like say you're dealing with congruent and you're dealing with maybe complementary or supplementary or whatever, then you can use substitution. But if I'm linking together congruent statements, I use transitive property because if we were linking together more than just a pair of congruent statements like we did here, I said 1 is congruent to 2, and angle 2 is congruent to 3. So therefore, 1 and 3 are congruent. If I had like, say, another pair of angles, I had like 3 is congruent to 4, and I wanted to prove 1 and 4 congruent, I could do that, but I'd have to use transitive property, or I'd end up having to actually use substitution twice. So please just make sure you guys are remembering to properly use those two, okay? So if you're linking together congruent statements, use transitive property. In this case, either one would work, but it's a little bit dangerous to mess with that, okay? But otherwise, we're good here. We're Gucci, as they say, in the streets of Huntley, right? I know my slangs. I got street cred. Let's see here. Angle O is comp to 2. Angle J is comp to 1. I want to prove that O and J are congruent to each other. Let's think here. I've got a couple comp statements, right? So when I see comp going on, I'm thinking, ooh, maybe this is one of those cool theorems where I'm like, angles that are complementary to the same angle are congruent, or angles that are complementary to congruent angles are congruent. Well, I don't have any congruent angles yet. What could you say about 1 and 2? You are correct. Very good. They are congruent. Why? Vertical angles are congruent. That's right. All vertical angles are congruent. So if 1 and 2 are congruent, and I know that O and J are complementary to those two, then O and J have to be congruent, right? It just makes sense. Also, we have a theorem about that. If two angles are complementary to congruent angles, then they are indeed congruent themselves. Looky, looky, we got the proof already done. So let's talk that through again in case you're like, whoa, Mr. Allen, pump the brakes, brother. You going too fast. Mr. Allen's always going fast, you know what I'm saying? He's like Ricky Bobby, driving. I'm going to go fast. All right. I'm just kidding. I'll try and slow it down here. It'll be like Ricky Bobby after he crashed that one time he had to go slow. All right. And then we'll go fast again. So we got angle 1 and 2 are congruent. Angle 1 is congruent to angle 2. Vertical angles congruent. I hope you guys have seen Talladega Nights for that reason, you know. Let's see here. Angle 1 is congruent to angle 2. Vertical angles are congruent. Now I've got that that angle O is comp to 2. Angle J is comp to 1. So if they're complementary to the same angle, to congruent angles, then they are indeed congruent. And I'm just going to put some arbitrary values here, just some random values. If 2 is, say, like how about 40 degrees, then angle 1 has to be because they are congruent, right? They're vertical angles, so they have to be congruent. Well, if 2 is 40, then O has to be 50, and J also would have to be 50, right? So add them up, 90 degrees, right? So, congruent, Mr. Allen. So we got O and J are congruent, and that's just a random example. But I could do that all day. I could do that all day, baby. Woo! All right, so angle O is congruent to angle J. Comps of congruent angles are congruent. America. All right, last problem. No proofs. No proof here. We're done with proofs for today. Last problem of the day. Last problem of the video, anyways. So I've got the measure of angle 13 is x squared plus 3x, and the measure of angle HJC is 2x plus 56. Let's jot that down. X squared plus 3x and 2x plus 56. And I want to find the measure of angle 11, which is this guy here. How the heck am I going to do that? I don't have any information about it. Well, what do I know about these two angles that I do have information about? They are vertical angles. And what do I know about vertical angles? Vertical angles are congruent. And if they are congruent, their measures are, you guessed it, equal. Oh, snap. I got a quadratic. What do I need to do? Let's set her equal to 0. And we get to solve by factoring. My favorite F word, factor. The other one is function, and then also fraction. I love those. It's like the trifecta when it comes to words starting with F. Function, factor, fraction. America. Alrighty, so what multiplies to negative 56 and adds to 1? I believe that would be 8 and 7. Woo! So if I solve for x, I get negative 8 and I get positive 7. Now, does only one of them work? Do they both work? I don't know. Let's see here. Well, if I look at my angle measures, if I pop in negative 8 up to the top one, that's going to be 64 plus 3 times negative 8. That's negative 24, so that equals what, 40? And if I pop it into this guy here, negative 8 times 2 is negative 16, plus 56 is 40. All right, well, those are both positive. That's cool. That's great. What about if I plug in 7? Will that still work? Well, 7 squared is 49, plus 3 times 7, that's 21. That's going to equal, let's see here, 21 plus 49. That's going to be 70. I think so. And what about this bottom one here? If I plug in 7, that's 14 plus 56 is also 70. Well, look at that. They both check out. So I'm actually going to have two answers here, but let's make sure we're answering the question. All right, so the one that's associated with the red 40s, what do we have here? We've got 40 for each one of those angles, so what's 11 going to be? Well, 180, because it's a straight angle we're dealing with right there, right? This is a straight angle. So 180 minus 40 equals 140. So that's one of our measures. And then if I do the same thing for the one in blue, it's going to be 180 minus 70. That's 110. Boom. Two different answers. If I didn't have both, I'm not getting full cred. All right, we want to get full cred because full cred leads to street cred, and you got to have that, right? Got to have street cred, and honors geometry is the first way to do that. All right. Quiz mañana, and then test the following week, right? Woo! Sounds like fun. This is great. You're going to get to do all sorts of fun stuff. Freedom.